Hello everyone and welcome to LeetTutorials. Today we're gonna solve evaluate reverse Polish notation. So we're given an array of strings tokens that represent an arithmetic expression in a reverse Polish notation. We need to evaluate the expression and return an integer that represents the value of the expression. So reverse Polish notation is a mathematical notation where the operator comes after the operand and the operator acts on the last two values that come before it. While calculating the final result, we're going to keep that in mind. And the question further adds that the valid operators are plus, minus, star, and forward slash. And each operand may be an integer or another expression, and the division between two integers always truncates towards 0, and there won't be any division by 0. And the input represents a valid arithmetic expression in a reverse Polish notation, and the answer and all the intermediate calculations can be represented in a 32-bit integer. This additional note is given by the question for us not to worry about various edge cases. In an interview setting, however, we would discuss these edge cases with the interviewer, so these points are important. Now let's take a look at some examples to better understand the question. In the first example, we're given the following tokens. Going from left to right, we need to first evaluate the result of this summation, and the result is going to be the operand of this multiplication along with this 3. Notice that we need to first evaluate this summation, and it's going to be reduced to a single number, which is 3, and this 3 is going to be fed into the next operation, which is multiplication, which then evaluates to 9. We can verify this by looking at the expression given by the question. We first evaluate this part, and we know that this evaluates to 3, and then 3 times 3 is 9. And in the given tokens array, we determine which operation to perform by looking at the symbols themselves. For example, this plus represents a summation, and this star represents a multiplication. In the second example, the first operator we see is a forward slash, which denotes the division between 13 and 5, which evaluates to 2 as we truncate the result towards 0. Then 2 becomes the right operand in the addition operation between 4 and 2, because these are the two immediate numbers that come before the plus sign after we evaluate this expression. We can verify this by taking a look at this explanation, where we see that we need to perform the division first, where the result of this expression evaluates to 2, so 4 plus 2 is equal to 6, so we need to return 6. So before jumping at the solution, we can make some observations about the input. We see in the examples that as we go from left to right, if we see an operator token, we need to perform that operation immediately, and the result should be saved and used in other operations without changing its order relative to other tokens. Also, the operations must be performed on the last two elements that come before the operators. So, in light of these observations, let's think about how we can solve this problem. As we go from left to right and encounter an operator in our tokens array, we need the last two elements, so we need a last in first out type of data structure to conveniently access them in constant time. Thus, a stack would be the perfect data structure to use here. So we will iterate over the tokens from left to right, and as we encounter numbers, we're going to push them to our stack. Then, as we encounter an operator, we're going to pop the top two elements from our stack, which are going to be the last two elements before the current operator. Then the necessary operation will be performed according to the type of the operator. Then we will push the result back into our stack and continue our iteration over the tokens array using the same logic. This way, we ensure the correct sequence of operations and access the necessary numbers and intermediate results in an efficient manner. The given input tokens are arranged in such a way that after we perform the necessary operations on the numbers, we end up having a single result, which will be the top and only value of our stack after we're finished. Now let's see how this algorithm works on an example. Now let's say we have the following tokens array, which is the same as in the third example. We will first define an empty stack and start our iteration over the tokens. First we encounter this 10 and see that it's not an operator, so we add it to our stack. And then we go over to this 6 and see that it's an integer, so we add it to our stack as well. And then we go to this 9 and add it to our stack. And then we go to 3 and add it to our stack. And after the 3 we encounter a plus sign, which represents an addition operation on the last two elements of the stack. So we pop the last two elements, which are 3 and 9, and add them together, which evaluates to 12, and add this result to our stack. After that, we're going to encounter a negative 11 and add it to our stack. And then we encounter a star, which represents a multiplication operation. So we pop the last two elements from our stack and multiply them together to obtain negative 132. And then we see a forward slash, and then pop the last two elements from our stack and divide them. 6 divided by negative 132 evaluates to 0 because in the division operation, the result is truncated towards 0. So we'll push 0 to our stack. Now we see a multiplication here, and we pop the last two elements from our stack and multiply 10 by 0, and we obtain a 0 again, so we push it to our stack. And then we'll encounter a 17 and push it to our stack. And then we'll encounter a plus sign, so we need to evaluate the summation of the last two elements, which is 17. And then we see a 5, and then we add it to our stack. And lastly, we see a plus sign, which denotes a summation between the last two elements, so we pop them from our stack and add them together to obtain 22. And now we're out of bounds, and our stack holds the value of 22, which we need to return as a result of this whole expression. And as you can see in the third example, the output is 22, so our algorithm is correct. Now let's talk about the time and space complexities. The time complexity of this algorithm is O of n, where n is the length of the tokens array, and the space complexity is also O of n. This is because we will visit each token once, and the length of the stack is upper bounded by the number of integers in the array. Now let's code this solution. The first thing I'm going to be doing is initialize an empty stack. In Python, lists have stack-like properties, so I'm going to be using a list here. And now I'm going to be iterating over the tokens array. And as we have seen in the question prompt, tokens can either be integers or operation symbols, so we need to handle those cases differently in our code. So I'm going to first check if our token is an operator. So this is a very basic way of saying if our token is equal to any of these symbols. Now we need to pop the last two values from our stack. The first one is going to be our right operand, and the other one is going to be our left operand. And if our token is a plus sign, the result should be the summation of left operand and the right operand. Else if the token is a minus sign, our result is equal to left op minus right op. And else if our token is a star, our result is left op times right op. And in the else case, we have a forward slash, so our result is equal to left op divided by right op, but we need to truncate this towards 0. We're going to deal with this by casting it to an integer, because in Python, casting to an integer truncates floating values towards 0, which is what we want in this case. And after we calculate our result according to the token, we need to append it to our stack. And if this if statement evaluates to false, this means that we have an integer value. So in the else case, we need to append the token to our stack. But note that this token is a string value, so we need to first cast it to an integer before appending. And that's actually all we have to do in this for loop. If we encounter an integer, we immediately append it to our stack. And if we encounter an operator, we pop the top two elements from our stack and evaluate the result according to our operator type and append the result back to our stack and continue our iteration over the tokens array. And as I've mentioned before, we're guaranteed to have a single valid value at the end of our evaluation. So at the end of the for loop, our stack is going to hold a single value, which we need to return as a result because it's the evaluated value of our reverse polish notation. So now we're going to return stack.pop, which is going to give us the top and only element of the stack. And that's it. Now we can hit submit. As you can see, our solution is correct and pretty efficient. I hope you found this video helpful, and if you did so, please like and subscribe. I really appreciate your support to the channel a lot, and I'll see you in the next one.